Hello everyone, welcome back to Day One Dev. Next few videos, I'm going to talk about more machine learning and MLOps. So the first video I'm going to talk here is a high-level architecture diagram before we do a deep dive in future sessions. All right. So you can see here high level, which I called out as a source systems, which where you get a different kind of a source of a data from various systems, whether it's in a SQL format, no SQL format, files, whether you're using a SFTP or a structured data, it can be, or a form-based data, or it can be unstructured data. And also you'll have some streaming platforms, and you might be integrating with an external systems where you might be doing all the stuff, right? So once you have all this data has been aligned from your systems, then you might be moving towards your data warehouse systems or data systems, you can call that. And within a data systems, you have a various systems where you're getting in warehouse, lakes, data lakes. You might be doing lake formation, data mesh, data mart, data stores, or you call anything. But there are two major concepts where the data ends up in your data warehouse systems, either using ETL format or ELT format. So ETL is one of our old terminologies if you are using like a products like Informatica, data stage and all, where you extract, transform, and load. But if you are in a cloud-based systems like Snowflake, Databricks, Redshift, where you might be using a term called ELT, where you extract, load, and you transform on a cloud. Right? So once you get all this data, that's where you do an data engineering and work. Or you call also you might be hearing a term feature engineering if you are more high level architecture towards a machine learning focused. So from here, you will use a data engineering or feature engineering to create a feature store. And you might also heard a couple of times you might have called a CSV file you're generating of a data using various formats of a feature engineering or data engineering. You might have heard also terms like using a Python and Apache Airflow, or you might have used terms if you're on a cloud oriented, you might have used AWS Glue or Apache's PySpark frameworks. You do this to generate your feature store data. So once this is where you get all your data, and that's where one of our data scientists he will create a machine learning model to uh, he generates a notebook, and that's where the entire model, and I'll be picking up certain algorithms where he'll be doing all this model part. So before creating a model, you might be seeing here various things to train a model, evaluate a model, and as you're saying a model. When you save a model, depends on certain repository management, you will be keeping all these models. If you're not managing any repositories to save a models, you might be saving them in S3 bucket or a storage or network drive. But if you're using SageMaker, there is a model repository which comes within a default SageMaker. Or you might have also heard MLflow, or you might have used JFrog Artifactory to use model repositories. Now, once you store this models, that's where the typically ML engineers will create a ML pipeline where they build an Python code, either using a Flask or Fast API, and they will create a Docker. So now, based on your model, is it in a text-based model, or you want to do an uh, NLP, which is a text, is most of them are NLP, or if you are using kind of a audio, video, or images, then you might be adding a GPU. to your Docker image when you're creating it, as well as when you're deploying under Kubernetes. You might have a GPUs are defined here, where you might have defined taints and torrents, where you'll be attaching certain worker nodes within a GPU nodes. And when you deploy your Docker image to a particular GPU-based models, you'll deploy there and you create as a service on that. So depends on your problem you're solving. It varies. And also you define some hyperparameters here when you're doing all the stuff, uh, containers and your platforms. So if you're not familiar, what is a hyperparameters? It's maybe I can put in a simple term. There are variables that control that training process through model somewhere here. And you also use them when you're deploying towards your Kubernetes because you need certain parameters based, you're defining it. That's where you define all this in ML model, sorry, ML pipeline, not a model. So once you deploy your service, it becomes now technically, if you're an application background person, once you deploy a service, you do a lot of monitoring tools, which you might have seen that if system goes offline, you might be sending in a notifications, either a Slack or PagerDuty, you might have used it, and they get a notification, the team will log in and do it. So in this scenario, the service might be experiencing, because this deployed in a Kubernetes, so service might be experiencing some high usage, and now you need to go back, look at why this is triggering that kind of a usage and all that stuff. And on top of that, you create an observability where you create a metrics to understand the usage of your system, and you do a trail of your data. All right. Now, if your coming background is an application, you might have not heard a term called accuracy drift. What does that mean is when you're building this your service, you need to your technically your understanding a degradation of your accuracy, and when you're not seeing this data, especially during a production, that is where the accuracy of your service might be, or accuracy of a model will be uh, going down beyond your threshold. What your expected is 90%, or a lower, which is you might have called a 80% threshold of your accuracy. If it falls down, you have to go back and based on your metrics, you go back and get the data, new data, and you process then a new retrain back. Is once you get this back, you collect the new data, you create a new feature store, and you move forward like this. So you're building entire part. The model might be algorithm. Data scientist needs to review this model, whether this model has been aligned to the data, what you're calling out, what have been tested out, or if it's totally new, you might need to tune your model, and you might need to go back, or you might need to change the algorithm, depends on kind of a problem is, and you will redesign entire, uh, build it, new model, and you might be, depends on how you configured, how you created your pipeline, whether you can reuse this entire model, and or you might be replacing only a model value and restart your new pods. You're good to go. You don't need to do most of this pipeline work. So all this depends on how you designed it on your side. So if I were you, I try to do most of a ML pipeline as a code whenever I find a drift. If I get a new data, I put in a monitoring on that code pipeline. New data has been arrived, and I retrain that back entire stuff. So if you need a sample code for this, they should be on my GitHub called ethnicity prediction, on which has been tested out on my AWS cloud environment. All right. I hope you learned something new. And if you have any questions, please comment on my day one channel here, and I'll be happy to respond to your uh, questions. And please share your feedback too. All right. I hope something I brought up a new point to give you a big picture of entire data ops, ML training, pipeline, and also talking about monitoring, accuracy drift, deductions, and trail. And these are one of our ML pipeline best practices, which I have worked with the various customers during my work. All right. I hope I'll see you in the next video. And please subscribe to Day One Dev, and I'll see you in the next discussion.